Adult Solutions. Add-on desired.
Hello students, glad to be here with you. Welcome to the Adult Solutions. I am Chandrakant, chemistry facilitator. We have completed atomic structure, right? The microscopic world. We learned all the principles, whatever the subject, the concepts involved in the atomic structure. Now, the atoms are combining to give the molecule, and the process, the bond between the atoms is called a chemical bond. That lesson, the principles, the procedure, how to write the molecules, everything let us explore now. Okay. See, this video related with content and objective questions together. Wherever it is objective question required the content, we do the content related to the objective question. Okay. See, which of the following element do not form molecule? Where the atom having not sufficient electrons, then that will form the bonding. If the element having sufficient electrons and that is stable, like zero group elements, helium, neon, argon, krypton, xenon and radon, they don't want to participate in the bonding. Rest of elements, they will participate in the bonding for the stability. Atom are less stable, molecule is better stable because they have more energy. Atoms have a more energy. Molecule will have a less energy, so stable. During the atoms approach together, when atoms are approaching together, the last orbit electrons will rearrange, they will reorganize. These reorganized process, they will lose the energy. That makes the stability to the molecule. Okay. So the helium is the atom which don't participate in the molecule. Oxygen can participate in the bonding to give O2 molecule. Nitrogen will participate in the bonding to give a nitrogen molecule, whereas argon, helium and argon do not form molecule because they are stable. What they have? Argon last orbit, that is 8 electrons are present. Helium duplet configuration, it is stable. Helium duplet configuration stable. Okay. Which inert gas has a duplet configuration in its valence shell, last orbit? Helium atomic number 2. It is first period element. Number of periods equal to number of orbits. Helium, only one orbit will be there. It is having 2 electrons. Neon, second period, 2 orbits will be there. Okay. So first orbit 2 electrons and the last orbit 8 electrons. Okay. So then we have the answer helium only. Neon, argon, krypton in the valency orbit, they have 8 electrons. Let us write all elements and their electronic configuration once. See, the helium, neon, argon, krypton, xenon, like that. Helium 1s2, neon last orbit ns2 np6, 2s2 2p6, argon third period 3s2 3p6, and the krypton 4s2 4p6, xenon 5s2 5p6. This is the last orbit electronic configuration. In the last orbit 8 electrons, correct? So duplet configuration helium. Assertion and reasoning type. Duplet configuration implies that a given atom has 2 electrons in its valence shell. Yes, it's true. Elements with octet configuration in their valence shell are stable. That is also the right statement. See, assertion is correct and reason is also correct. Okay, fine, that will be the option C. When you read these options, option C is the right answer for the given statements. The duplet and octet configuration of an electrons in the valence shell is a most stable, and any atom having this configuration will be in minimum state of energy. This statement was given by related to the direct factual information, the scientist whose observation it is. That is Lewis and Kosel. Lewis worked on organic molecules, whereas Kosel worked on inorganic molecules. Both are same output, different countries, independent work it is. Lewis and Kosel, they have done their independent work with the same concept. Okay, so Lewis and Kosel concept it is. Okay, minimum energy if they have duplet configuration or octet configuration in the last orbit. To attain dash participating atoms redistribute their electrons to get the electronic configuration of the nearest noble gas, either octet or duplet. That is, to obtain a minimum energy or a maximum stability. When the atoms are approaching together to form a molecule, when atoms are approaching together to form a molecule, they lose energy. So the atoms will have more energy and the molecule will have a less energy, so that it is stable. To attain a state of a minimum energy, here we need to write the state of a minimum energy, then that is stable. The units will be stable. Why the minimum energy? Electrons in the last orbit reorganizing, so that they will facilitate to lock together, to bind together. That's what we call chemical bond. Energy lost by the electrons during the rearrangement, so that the molecule is stable. The dots in the Lewis symbol represent, that is, last orbit electrons, valency electrons, last orbit electrons, that is correct. Not the low energy state or octet, nearest noble, no. If you see the hydrogen atom, this is the Lewis dot model. If it is helium, yes, we have the 2 electrons at helium. Okay, last one orbit 2 electrons. If you have the oxygen atom, 6th group, this is the Lewis dot model. If it is carbon, so valence electrons are 4, carbon 4th group. Consider that a nitrogen atom, it is the nitrogen atom, 5th group element, 5 electrons. Valence electrons in an atom given by the Lewis dot model. The common or group valency is equal to, the group valency is equal to a group number of valency electrons till a group number 4. Yes, it is correct. Nitrogen valency, that is combining ability, not 5. Combining ability of nitrogen is 3 or 4, but not 5. Group number not equal to valency from the 5th group onwards. Only up to 4th group, that is carbon, silicon, germanium. 4th group it is accepted. Group number equal to combining ability. Nitrogen cannot give the 5 bonds. Okay. Then common or group valency is equal to 8 minus number of valence electrons after group number 4. Yes, it is accepted. Let us take nitrogen atom. 8 minus 5, its group number. Nitrogen combining ability 3. Even you take oxygen atom, 8 minus group number 6, combining ability 2, nitrogen valency 2. So the general formula for the second period, it is accepted. Only number of electrons present in the valency shell. No. Every element it is not validated. Right? So A and B are the answers for the given statement. Highly electronegative halogens. Highly electronegativity. What is electronegativity? The bond pair, a pulling ability towards itself in a molecule, the atom which is pulling the bond pair, not electron, the bond pair, that ability is called as electronegativity. Left to right, electronegativity increases. Halogens will have a more electronegativity, and highly electropositive alkali metals are separated by noble gases. Yes, it is true. When you imagine the periodic table, extreme left alkali metals, after that so many other group elements are there. At the end we have 7th A group elements, halogens, fluorine, chlorine, bromine, iodine, astatine, like that. If you take a property from left to right, there is a periodic trend. The property that may be increasing or decreasing, that will end at the 7th group. After 7th group, the property will start from the 1A, 0 group elements, not related with the periodic properties because they are not participating in any bonding, they are not responding. Okay, this is called a 0 group elements. So the helium, neon, argon, krypton, xenon and radon. Okay, so this fact is relation to chemical bonding was given by factual information Kosal. Halogens and alkali metals, lithium, sodium, potassium, rubidium, separated by 0 group elements. One has to view the periodic table not in a square manner. Imagine the periodic table in a cylindrical manner. If you join this sheet, periodic table sheet, when you join from the back end, then 1A group elements, and then after middle 0 group elements, and then halogens, like that they will be. Okay, then that is given by the Kosal observation. Who proposed ionic or electrovalent bond? Ionic bond or electrovalent bond. The electrostatic force of attraction between two opposite charged ions is called ionic bond. For example, you take a sodium atom and chlorine atom. Sodium atomic number 11 and the chlorine atomic number 17. Write the electronic configuration for the sodium. 1s2, that is 2s2 2p6, correct, that is 8 electrons in the second orbit. 2s2 2p6 and third orbit only 1 electron. First orbit and second orbit, third orbit. Atomic number 11. 11 electrons are there in the sodium atom. Chlorine, 17 electrons. 1s2, 2s2, 2p6 and 3s2, 3p5, 3s2, 3p5, correct? Then first orbit 2 electrons, second orbit 8 electrons, third orbit 7 electrons. If sodium losing 1 electron to the chlorine, it will become as octet configuration. Na plus last orbit will get 8 electrons only, so that Na plus is stable. Similarly, Cl minus, the last orbit, as it is acquiring 1 extra electron, that is a 2, 8, 8, the third orbit having 8 electrons. Due to the electron complete transformation, there are two opposite charges which will bind together through the electrostatic force of attraction, and that we call it as ionic bond, right? So this is proposed by, again, Kosal. Atoms can combine either by transfer of valence electrons from one atom to another or by sharing of electrons. Yes, that's what the bond formation. Sharing of electrons will bring the covalent bond and electron transformation will give ionic bond. Metals will lose the electrons to the non-metals. S block elements, 1A, 2A group elements are metals. Most of the P block elements, majority of the P block elements are non-metals, correct? The bond between metal and non-metal is an ionic compound. This is to complete their octet and acquire a nearest to noble gas configuration. Okay, so both A and B are correct. A is the correct explanation for the B. Yes, it is true. Electron transformation or sharing for the stability purpose only, to get a nearest octet. Okay, so the option A. Which of the following compound do not follow octet rule? CS2, carbon disulphide. This is the structure for carbon disulphide. There is a octet, carbon having 8 electrons. You can count here, one line is nothing but 2 electrons. The bond which belongs to both atoms. Then carbon how many electrons? Accountability 8. Sulfur how many electrons? 2 plus 2, 4 and 4, 8. In the carbon disulphide, every atom having 8 electrons. Think about PbR3, phosphorus tribromide. Phosphorus tribromide. Here, phosphorus how many electrons? That is 6, 7, 8. Correct? Phosphorus central atom, it is having 8 electrons. And IBr, iodine bromide. Okay, this is the structure of iodine bromide, is also 8 electrons. Okay, iodine and bromine also 8 electrons. You can count it. Suppose iodine 1, 2, 3, 4, 5, 6, 7, 8. Similarly, bromide also 8 electrons. It is stable. Think about BrF5. BrF5. Bromine, how many electrons are there? Bromine, 7th group element. There are 7 electrons in its group. Okay, so the bromine, 5 fluorine atoms. 5 fluorine atoms. Then bromine consisting 7, out of 7, 5 participated in bonding, then there is one lone pair at the bromine. Okay, then it is beyond the octet. You can count to the bromine how many electrons? That is 2, 2, 2 plus 2, 2, all. How many electrons? That is 10 and 11, 12. 12 electrons are there beyond the octet. Okay, bromine pentafluoride having the central atom 12 electrons. Which of the following compounds follow octet rule? NH3, write the structure for that. It is the ammonia molecule, nitrogen atom having 8 electrons. Count that again, electrons 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. And H2O, again oxygen atom, central atom oxygen will have 8 electrons. You can count it. This is the water molecule. Oxygen 6th group element. Look at this. Oxygen 6th group element, there exist valence electrons are 6. Those electrons are participating in the bonding. PCl5, phosphorus, there are 5 electrons in its valence shell and every chlorine is participating bonding with it. How many electrons it is having? PCl5, that is 6, 7, 8. Which of the following compound follow octet? PCl5, then one chlorine, one another chlorine. Now phosphorus having 10 electrons after bonding. Okay, so this is not the answer. Sulfur 6th group element, valence electrons are 6 existed. Valence electrons are 6 existed. After bond formation, every fluorine is giving 1 electron. The bond pair belongs to both atoms. Okay, so the sulfur having 12 electrons. Okay, this is not the answer. A and B are the answers for it. 4 elements A, B, C and D have atomic numbers Z minus 1, Z, Z plus 1 and Z plus 2. They are in a sequence. Okay, atomic number increased. Okay, for Z is the reference, suppose as the atomic number Z is the reference, left group is 1 unit less, right group will be 1 unit more. If Z is atomic number 9, then the bond between which pair of element will be ionic? Z value 9, which element it is? Fluorine. Okay, Z atomic number is fluorine, F equal to 9, then obviously Z plus 1 will be 0 group element, that is neon. Okay, so Z plus 1 will be neon, atomic number 10. And Z plus 2 again after neon, sodium, which is coming to the 1A group element. This is a sodium, atomic number 11. Okay, before Z 1 unit less, that is 6th group element. Z minus 1 atomic number 8, that is oxygen atomic number 8. Now the question is, which pair of elements will be ionic? One metal, one non-metal will be ionic. If I say this is A, B, C, D, then ionic bond will be sodium and fluorine. BD, B and D is ionic compound. Out of the given available combination, B non-metal and D is the metal. Neon non-metal, oxygen non-metal, correct? So B and D compound. D will give cation, NaF. D and B, NaF, Na plus and F minus, ionic compound. Option C. Whereas cross check BC not possible, neon participating in any compound. Everywhere there is a C, A ruled out, B and D. All three options ruled out because neon is the C compound, do not form any compound. Any compound, not only covalent ionic. Okay. So option C is the right answer. It was found that atoms having atomic number 2, 10, 18, 36, 54 and 86 are very stable and do not show any chemical reactivity. These elements were found to be gaseous and are called inert gases, zero group elements: helium, neon, argon, krypton, xenon and radon. Helium atomic number 2. So 2 added with 8, we get the 10 atomic number. 10 added with again 8, argon atomic number 18. Okay. So the 18 again added with 18, so krypton 36. So 36 added with again 18, we will get that is 54. 54 added with 32, that is 86. This is what zero group elements and their atomic numbers. Inert gases, diatomic is wrong. They are monatomic gases and they are also called as noble gases because they don't want to participate in the bonding. Except B, A, C, D are the right answers. Chemical reactivity of an element depends on, as we came across in the periodic table, modern periodic law, physical and chemical properties are the periodic functions of their atomic number and electronic configuration. There we are, the statement, outer electronic configuration is the responsible for the chemical properties. In the chemical properties, nucleus is not the role, core electrons, only outer electronic configuration, option A. If the magnitude of attractive forces is more than those of repulsive forces, then the potential energy of the system increases. See, when the atoms are coming together from the infinite distance, at infinite distance they have a maximum potential energy, correct? Then when the atoms are coming together, their potential energy decreases. When the molecule formation takes place, there attractive forces and repulsive forces both will be in the equilibrium. Minimum repulsive forces takes place. Attractive, electron of one atom. Okay, so electron of one atom, nucleus of one atom, there is attractive force. Okay, electron of one atom and a nucleus of one atom, there is an attractive force. In between nucleus and in between electrons, there will be a repulsive force. These two are equilibrium when there is a bond formation. Okay. If the magnitude of attractive force is more than the repulsive forces, then bond formation takes place. The potential energy of the system increases. No, attractive forces, when the atoms coming close together, molecule formation takes place, potential energy decreases. Statement A is wrong. With the decrease in potential energy, system gains stability and the chemical bond formation takes place. Yes, it is. Right statement. A wrong, B right statement. If in forming compound AB, an electron is transferred from A to B, and then that is ionic compound. The compound is electrovalent. Okay, which of the following statements concerning elements with atomic number 10 is true? Atomic number 10, neon, last orbit, complete octet it is, and it is an inert gas. Neon is an inert gas. Its molecules are monoatomic. Neon is monoatomic. It do not form any bonding. Okay, so the B, C, D are the answers. Which one of the following compounds does not follow octet rule? Where there is no octet rule, CO2 molecule, it is octet, carbon having 8 electrons. PCl3, again phosphorus having 1 lone pair and 3 chlorine atoms, it is also octet. ICl3, ICl, iodine, central atom having 8 electrons. ClF3, ClF3 is the T-shaped molecule, fluorine, fluorine and fluorine. So the how many lone pairs will be there at ClF3? There will be 2 lone pairs. It is crossing the octet. More than 8 electrons are there at Cl, central atom. How to calculate the lone pairs? Be good at the formula, note down this. Number of lone pairs equal to valency electrons of the central atom plus or minus charge of the given unit minus number of electrons gained during the bond formation by 2. Valence electrons plus or minus charge minus number of electrons gained during the bond formation by 2 will give you lone pair. Do we have any charge in it, ClF3? Is there any charge? No. Chlorine, which group element it is? 7th group. Okay, so write 7 there. There is no charge on it. If it is positive charge, remove the electron. If it is negative charge, add electron. Okay, 1 fluorine is providing 1 electron, so 3 fluorines will provide 3 by 2. So the number of lone pairs we will get it as 4 by 2, that is 2 lone pairs. Chlorine atom, number of lone pairs are 2. Be good at this formula. Lone pairs. Central atom, balance the electrons plus or minus charge minus number of electrons gained by 2. Okay. Then chlorine, how many electrons are there? 6, 7, 8, 9, 10. It is the answer D. Does not have octet, beyond octet. The compound which does not contain ionic compound. Metal Na plus and OH minus, it is ionic compound. Okay, it is ionic compound, and HCl is a covalent compound. If the bonded atoms electronegativity difference is less than 1.7, covalent more than 1.7, that is ionic. Hydrogen electronegativity approximately 2.1. Chlorine, it is approximately 3. So the difference between 0.9, which is 0.9 is less than 1.7 approximately. If any bonded atom, the electronegativity difference is less than 1.7, that is a covalent. More than 1.7, ionic. Answer is B, which is covalent. K2S, ionic. Lithium hydride. Lithium hydride is a covalent character. What is the basis for that? Even lithium is an metal. Lithium compounds can be covalent, lithium and beryllium, because of this reason, that is polarization. Okay, if an anion and a cation, when the small cation and more charge, cation having more charge and small size, more charge and small size. If the cation is small in size and more charge, if it is coming very close to the anion cloud, negative cloud, electron density, then the molecule will become as like this. The electron cloud looks like as a dragging. That is called polarization. More polarization, more covalent character. Lithium and beryllium plus 2. Even they are metals, they can form the covalent compounds. The bonds of them are covalent in nature. Then lithium hydride is a covalent nature, HCl is a covalent. Okay.
Add-on solutions. Add-on design.